Hello, thanks for joining me. Today we're going to just look at some sample problems involving translating words into equations. Now, we're translating into equations, so we're going to be looking for equalities. We'll look for some keywords that indicate an equality, but we're not going to solve these equations. So I'm not even going to show you the solutions, because this is not about solving the equation, it's just about getting the words into an equation form that we can then solve. Okay, so this first one gives us, this is a kind of a typical thing. We've broken it down into two lines. The question that we're being asked is how much money does each have? And that's the first thing we do. We just want to look for what are the unknowns, or what is the unknown. And we're going to try to create a one variable equation. So we're going to identify a variable, but notice here we have two unknowns. We have Alvin's money. Alvin has some money, and then Beth has some money. So we've got Alvin's money, and we have Beth's money. So there's two unknowns. I'm going to write myself two variables, even though my goal is to get rid of one of those variables and just have one. I think it's going to be helpful for me to start off with the two. So, for example, the first sentence, Alvin has twice as much money as Beth. Now, I hope you can see at least one math word there. We have the variable Alvin's money is A, and the Beth's money, that's B. And then twice means two times. Two times what? Two times twice as much money as Beth, so twice Beth. And then this word here, has, is going to be what stands for the equals. I think you can see that has, is, so it's possession. It means equals. The amount of money that Alvin has is equal to two times or twice the amount as Beth has. Okay, that's an equation. We can write that down again. We translated it, but we can rewrite it in kind of simpler form. A equals 2b. Okay, now let's look at our second equation. I'm going to change pens here. Our second sentence, together they have $63. So together, what kind of operation is that? Together. They would be Alvin and Beth. So Alvin and Beth together have, right? That's like has. So together they have $63. So that looks like the have is the equal sign. And then there's 63. And together, I hope you are thinking or yelling at the screen, that stands for addition. So A, oops, said A, but I wrote something else. A plus B equals 63. Now, here's the deal. The second equation shows kind of when you put the two unknowns together, what you get, right? A plus B equals 63. The first equation says, well, one of those unknowns is comparable or has some sort of comparability relationship with the other. So A is comparable to 2B. So if we see A anywhere, we could replace it with 2b, and that's what we're going to do. That's the key. So we're going to say, well, we do have an a here, but if we wanted to, we could replace it with 2b. So 2b plus b equals 63. And we could stop there. We could say we're done. That's it. You may want to take the extra step and depending on where you're working this, what textbook you're using, you might take the extra step of saying, oh, wait a second, 2b plus 1b, we can do that. That's 3b. But technically, that's working out the problem. Now, was this the only way to do this problem? this is one of the things that's a little bit of a problem with these word problems. There's more than one way to think about it, and your way of thinking about it might be a little bit different than mine. But technically, we could have said, well, since A equals 2B, B equals 1/2 of A, right? If the amount of money Alvin had is twice as much as Beth, then the amount of money Beth has is half as much as Alvin. So then we could say A plus B, oops, 1/2 of A equals 63. And that's a little bit harder math problem, but we could do 1A plus 1/2. A is 3/2. A equals 63. Now, if we solve that second equation, we're going to find out how much money Alvin has. If we solve the first equation, we'll find out how much Beth has. We don't typically set up two equations like this, but I just wanted you to see that there is more than one way to set this up, just in case you set it up and then the answer key you're using sets it up differently. Okay, let us move on. The length of a rectangle is 4 units more than its width. If the area is 45 square units, find the dimensions of the rectangle. Okay. How are we going to do this one? This is a problem that is a really good example of the kind of problem that you would want to draw a picture for. We've got a rectangle, so let's draw a rectangle. And rectangles have a length. I'll use the letter L. I'll use a cursive letter L. That's a convention that we use a cursive letter L because if I used just a line, it would look like a 1. So I use try to make that into an L. And then a width. Since I used a kind of a cursive L for the length, then I'll use a cursive W for the width. If the area is 45 square units, find the dimensions of the rectangle. The length of the rectangle is 4 units more than its width. Now, here's the thing about rectangles. The opposite sides are the same. So if this is the width, then this is also the width. And if that's the length, then this is also the length. But remember, the length is 4 more than the width. So it's 4 plus W. So now we have a separate representation for length for the length. The length could be L, or it could be 4 plus W. And now we need to do that. That's that first sentence. The length of a rectangle is 4 more than the width. Okay, the area is 45 square units. Now, area is a code word. If you didn't know what area means or what the area formula is, then you can't do this one. The area formula for a rectangle goes like this. The area of a rectangle, you know this already, is the length times the width. So now we can fill in all of these variables. The area is 45. The length is, well, the length is 4 plus W. 4 plus W. And the width, well, since we know what the length is in terms of W, we can just keep the width in terms of W also. And there we have it. We could turn this around and say W times 4 plus W equals 45. We might see it as W times W plus 4 equals 45. And somebody might want to take the step of distributing that W. So saying W squared, whoops. Grab my W squared plus 4W equals 45. It doesn't matter, we're a long way from being able to solve an equation like that, so it doesn't matter which of these ways we chose to set it up. all of them are correct, and then we will figure out how to solve these later. Okay, thank you very much for watching. Have a great day.